Welcome to the Deep Dive, where we take fascinating sources and pull out the knowledge you need to know fast. Forget endless reading, we do the digging for you. Today we're plunging into, well, a true cornerstone of Western thought, Aristotle's Nicomachean Ethics.
That's right. And our guide for this exploration is the comprehensive overview you can find on Wikipedia. It's a great way, really, to get a handle on one of history's most influential thinkers on, how to live a good life.
Okay, so our mission today.
It's basically to pull out the most important, the most intriguing ideas from Aristotle's ethical framework, ideas that honestly still resonate and can offer some surprising insights for how we navigate our own lives today.
Aristotle's Nicomachean Ethics. Okay, it sounds pretty serious.
Right.
But this isn't just some dusty old academic text, is it? I mean, why are we still talking about this now?
Well, think about it. Aristotle, way back in ancient Greece, he was asking a question we all still ask. What's the ultimate point of life? What are we aiming for?
Right, the big questions.
Exactly. And for him, ethics wasn't just theory. It was a practical guide to achieving what he called eudaimonia.
Eudaimonia, okay, I've heard that term. It's more than just happiness, yeah.
Much more. Think, flourishing, living well, really hitting your full potential as a human being. And his ethics is tied directly to his other big work, the Politics.
How so?
Well, he saw ethics as focusing on the good life for the individual, for you. And politics looked at the good for the whole community, the bigger picture.
Okay, so it's like personal development meets social responsibility, all rolled into one ancient Greek package.
You could put it that way, yeah. And the influence. It's been massive. I mean, for centuries, this book was the foundation for ethical thinking in the West.
Really?
Oh, yeah. It shaped medieval philosophy, European law, even theology. Thinkers like Thomas Aquinas just called him the philosopher, period.
Wow. The philosopher. This says a lot.
It really does. That kind of lasting power suggests he tapped into something fundamental about the human condition.
But the Wikipedia entry does mention his ideas weren't always, the top dog. There were challenges.
Oh, absolutely. Come the 17th century, you had figures like Bacon, Hobbes. They felt the whole Aristotelian way of thinking was maybe holding back scientific progress. But interestingly, more recently, there's been this big revival, something called virtue ethics. It shows his ideas about character, about how we develop as people. They still have a lot to offer, even now.
That's fascinating. Now, the title, Nicomachean Ethics. Any story behind that? Does it tell us anything?
Well, the main theory connects it to his son, or maybe his father. Both were named Nicomachus. So it might have been dedicated to one of them, or maybe his son helped edit it later. We don't know for sure. But what's really interesting is the style. It reads a lot like lecture notes.
Lecture notes. So like we're almost eavesdropping on his class.
Kind of. It gives it a very direct feel, like we're getting his thinking process almost unfiltered.
Cool. The entry also mentions Becker numbers. What are those about?
Yeah. That's just the standard system scholars use to refer to specific parts of the text. It was developed by a 19th century scholar, Emanuel Becker.
So it lets people pinpoint exact lines.
Exactly. Page, column, line. It just shows you how incredibly closely this text has been studied over, well, millennia, really.
People poring over every word. Okay.
Perfect.
And there's this overlap mentioned with another work, the Eudaimonia Ethics. Sounds a bit complicated.
It is a bit of a puzzle. 3 of the books are basically identical in both works. So scholars argue, were they originally part of the Nicomachean or the Eudaimoian? Or maybe shared lecture material? It's a good reminder that these ancient texts didn't always come down to us in neat, tidy packages.
Right. And the timeline, when was this actually written?
We're talking probably around 335 to 322 BCE, while Aristotle was back in Athens running his school, the Lyceum.
And getting it from then to now wasn't straightforward.
Not at all. After he died, his library went through several hands, was apparently hidden in a cellar for a while. Not great for preserving papyrus scrolls. Eventually, the texts made their way to Rome, where they were edited and compiled into something closer to what we have now. But luckily, we have early commentaries, like from Aspasius in the 2nd century CE, that show the core text was pretty stable even back then.
Okay, so that's the history. Let's dig into the core ideas. The entry talks about a teleological approach. What does that mean in ethics?
Teleological just comes from telos, the Greek word for end, or purpose, or goal. Aristotle believed everything has a purpose, a function.
Like a knife's purpose is to cut.
Exactly. So to understand how humans should live, he thought we first need to figure out the telos of a human being. What's our ultimate purpose?
And for him, that purpose is achieving eudaimonia. We mentioned it earlier. Flourishing.
Precisely. It's the highest good for humans. But again, not just feeling happy moment to moment, it's about activity. It's the active exercise of the soul's faculties in accordance with virtue or excellence.
Active exercise of the soul. Okay, so it's about doing things well, using our abilities.
Yes, living well, functioning well as a human. And it's the ultimate goal because, well, we choose it for its own sake. Everything else we want, wealth, honor, pleasure, we often want them because we think they'll lead to flourishing.
But flourishing is the end of the line.
It's the end of the line, the complete self-sufficient goal. And crucially, he says it requires a complete life. It's not something you achieve in a day.
Right, that makes sense. So how do we actually get there? How do we achieve this flourishing? That brings us to virtue, right? Ethika rito.
Absolutely. Moral virtues are the key. Think of them as excellent character traits or beneficial habits. They're the qualities that enable us to live well, to function excellently.
Like courage or patience or justice.
Exactly, those kinds of things.
Yeah.
And you develop them through practice, through habituation. It's like learning to play an instrument. You don't become a virtuoso overnight.
You have to practice the scales.
You have to practice the scales, you make conscious choices, you practice acting virtuously, and eventually it becomes part of your character, almost second nature.
The entry makes a distinction between ethos with a long E's character and ethos with a short E habit. Why is that important?
It highlights that character ethos isn't just mindless habit ethos. It's a stable disposition, yes, but one that involves conscious choice and reason. It's about why you do things habitually.
Got it. So character is habit plus intention, sort of.
In a way, yes, it's a settled state from which you choose your actions.
Okay. And the Wikipedia entry mentions 4 key virtues: magnanimity, justice, phronesis, which is practical judgment,
Right, practical wisdom.
and friendship. And these contribute to something called Kelekagathia.
Yes, those are central. Kelekagathia is this ideal of the noble and good person, someone who embodies excellence across the board. These virtues are crucial components of that.
Aristotle's method is interesting too. Started with common beliefs and working towards something more rigorous.
Yeah, he didn't just start from abstract principles. He looked at what people generally believed, what wise people thought, how language was used. He respected common sense, you could say.
But he didn't just stop there.
No, he pushed further, analyzing, defining, looking for the underlying logic. He tried to balance theory with, empirical observation of how people actually live.
And he famously took issue with his own teacher, Plato, on the idea of the good.
He did, respectfully, of course. In Book 1, he questions Plato's theory of forms, specifically the idea that there's one single universal form of the good that explains all goodness.
Why?
Well, Aristotle pointed out that we call lots of different things good: a good meal, a good person, a good strategy. He doubted there was one single definition covering all those uses. He thought it was more practical to focus on the human good, the good we can achieve through action.
Right. So back to the human good. He defines it as the soul's active exercise in conformity with virtue. And reason, logos, is key. That's our unique function, our ergon.
Exactly. He asks, what's the characteristic activity of a human being? What makes us different from plants or animals? And his answer is our ability to reason.
So the best life involves using that reason well.
Using reason well and acting in accordance with virtue or excellence. That's the core of human flourishing for Aristotle.
But it's not all internal. The entry notes he acknowledged external goods matter too.
Oh yeah, he was very realistic about that. While virtue is the core, he knew that things like having enough money, good health, friends, even good looks to some extent, and living in a stable society, these things make it easier to live virtuously and achieve eudaimonia.
You can be virtuous while poor, but it's harder.
It's certainly harder to exercise certain virtues like generosity or magnificence if you have no resources. So external goods have a role even if they aren't the main goal.
Okay, that makes sense. Let's move on to his famous doctrine of the mean. That sounds central. Finding a middle ground.
That's the essence of it. For most moral virtues, Aristotle argues they lie in a mean mesosis between two extremes, two vices. One is a vice of excess, doing too much, and the other is a vice of deficiency, doing too little.
Like courage, which you mentioned. Between cowardice and rashness.
Exactly. Cowardice is feeling too much fear or acting on it too readily. Deficiency of confidence. Rashness is feeling too little fear or ignoring risks. Excess of confidence. Courage is finding the right balance. Feeling fear appropriately, but acting rightly despite it.
So virtue is like hitting the bullseye between two misses.
That's a great analogy. And it applies to feelings as well as actions. The virtuous person feels anger, pleasure, fear, etc. in the right way at the right time towards the right people for the right reason.
And crucially, the virtuous person enjoys doing virtuous things, right? It feels good to do good.
Yes, that's a key sign. If you find it painful to be generous or courageous, you haven't fully developed the virtue yet. Pleasure in noble actions is a mark of a virtuous character.
And for an action to count as truly virtuous, it's not enough just to do the right thing by accident. There are conditions.
Right. He lays out criteria. You have to know what you're doing. You have to choose the action for its own sake, not for some ulterior motive. And the action has to come from a firm and unchanging character. It's about intention and disposition.
Okay, that leads into the whole discussion of voluntary versus involuntary actions. Why is this distinction so important?
Because it's fundamental to responsibility. We praise or blame people for their voluntary actions, the things they choose to do knowingly. Involuntary actions, things done under compulsion or through certain kinds of ignorance, well, they often deserve pardon or pity rather than blame.
And ignorance isn't always an excuse, is it? He talks about different types.
Correct. If you're ignorant of general moral principles, you just don't know that stealing is wrong. That's part of having a bad character, and it doesn't excuse you. But if you're ignorant of specific details of the situation, you didn't know the gun was loaded, for example, that can make the action involuntary.
So the details matter. What about deliberate choice, proeresis, deliberation, bolusis, and wishing, bolusis? He seems to be mapping out how we decide things.
He really is. Belasis, or wishing, is about our ultimate ends, what we desire, hopefully, the good. Belasis, or deliberation, is the process of figuring out how to achieve those ends, the practical steps. And proeresis, or deliberate choice, is the decision we make after deliberating, committing to a specific action that's within our power.
And his conclusion is that our character, whether virtuous or vicious, is ultimately up to us.
Yes. He argues strongly against the idea that people are bad unwillingly. While nobody chooses to be miserable, he believes vice comes from repeatedly choosing the wrong actions or pursuing the wrong goals. We build our character through our choices, so virtue and vice are voluntary.
Okay, let's get into some of the specific virtues, the entry details. They sound quite distinct. Courage, for instance. It's specifically about facing fear, especially in battle.
That's the primary context he discusses, yes. Facing the fear of a noble death, like death in battle for one's city. It's not just any fear. It's about facing the right fears, for the right reasons, like honor, in the right way. He also lists 5 things that look like courage, but aren't, like soldiers fighting out of fear of punishment or people being overconfident due to ignorance.
Interesting. Then temperance, sufrasuna, that's about bodily pleasures.
Specifically touch and taste, the most basic animal pleasures. Temperance is the mean regarding these. The excess, echolalia, is self-indulgence or intemperance. The deficiency, being completely insensible to such pleasures, he thought was pretty rare.
So enjoying a good meal is fine, just don't overdo it.
Exactly. Enjoy them reasonably, in line with what reason dictates.
Then there are 2 virtues related to wealth. Liberality, generosity, eleutherios, and magnificence, megalopropeia. How are they different?
Liberality concerns handling moderate amounts of money while giving the right amount to the right people at the right time and taking pleasure in giving. The extremes are wastefulness and stinginess. Magnificence is similar, but on a grand scale. It's about spending large sums appropriately on things like public works or religious offerings, fitting the expenditure to the occasion and one's means. Think large-scale philanthropy.
Got it. Magnanimity, or greatness of soul, megalopsuchia, sounds really important. It's about knowing your worth.
Precisely. It's thinking yourself worthy of great things and being worthy of them. Aristotle calls it a crown of the virtues, because the truly magnanimous person must possess all the other virtues to be genuinely worthy of great honor.
He gives quite a detailed picture of this person, doesn't he?
Oh, yes. The great-souled person is concerned primarily with honor, but doesn't sweat the small stuff. They give generously, but hate being indebted. They're open and truthful, maybe a bit slow in movement and deep-voiced. It's a very specific aristocratic ideal, quite different from, say, Christian humility.
Fascinating. Then there are virtues for everyday social life. Proper ambition, gentleness, friendliness.
Right. Proper ambition is the mean about seeking normal levels of honor, not being overly ambitious, but not lacking ambition entirely. Gentleness, praeosis, is the mean concerning anger, getting angry at the right things in the right way, not being overly irritable, but also not being passive when anger is called for. Friendliness is about social pleasantness, hitting the mean between being obsequious or fawning and being quarrelsome or grumpy.
And truthfulness, wit, and shame.
Truthfulness here is mainly about self-presentation, being honest about your own qualities, avoiding both boastfulness, excess, and false modesty or self-deprecation, deficiency. Wit or charm is about humor and conversation being amusing and good taste, the mean between buffoonery and boorishness. Shame, interestingly, he calls a quasi-virtue. It's a feeling really appropriate for young people who are still learning, but not something admirable in a mature, virtuous adult.
Okay, that covers a lot of character traits. Book V then tackles justice. He sees it in two ways.
Yes. First, there's justice as general lawfulness obeying the laws of the state, which, ideally, should aim to cultivate all virtues. Then there's justice as fairness in specific interactions.
And this specific fairness has types, too.
Right. He distinguishes distributive justice, how honors, wealth, or other goods should be divided among members of the community, usually based on merit or status. And corrective justice, which aims to restore a balance when an injustice has occurred in a transaction, whether voluntary, like a contract dispute, or involuntary, like theft or assault. He even gets into the theory of money here, seeing it as a way to make different goods comparable for fair exchange, based on need or demand. Crea.
That's surprisingly practical. Okay, Book 6 moves to the intellectual virtues. Why are these needed?
Because figuring out the mean, knowing what the virtuous action is in any given situation, requires good thinking. It requires intellectual excellence.
So moral virtue needs intellectual virtue to guide it.
Exactly. He divides the rational part of the soul into two. One part grasps unchanging truths, like math or philosophy. The other deals with variable things, like how to act in a specific situation.
And there are 5 intellectual virtues.
Yes. Episteme, scientific knowledge of necessary truths. Techne, art or craft knowledge, how to make things. Phronesis, practical wisdom, how to act well. Nous, intellect or intuitive reason, grasping fundamental principles. And Sophia, theoretical wisdom, combining nous and episteme to understand the highest truths. Phronesis is the ability to deliberate well about what is good and advantageous for life in general. It requires experience, understanding particulars, and allows you to determine the right course of action, the mean, in any situation. It's the intellectual virtue most directly connected to moral action.
Right. But what gets in the way? Book 7 talks about impediments. Vice, incontinence, brutishness.
Yes, he looks at the states opposed to virtue. Vice is the subtle disposition to choose badly. Incontinence, or acrasia, is weakness of will, knowing what's right, but doing something else due to passion or desire. Brutishness is a rare, almost subhuman state of extreme depravity.
How does incontinence, acrasia, differ from vice?
The vicious person thinks their bad actions are actually good or doesn't care. Their reasoning is corrupted. The incontinent person knows on some level that what they're doing is bad, but their desires or emotions override their judgment. They feel regret afterwards, unlike the truly vicious person.
So it's a conflict within the person.
Exactly. Aristotle even tackles Socrates' idea that no one does wrong knowingly, suggesting acrasia involves a kind of breakdown in the practical reasoning process, where knowledge of the general principle gets overwhelmed by desire for a particular thing.
Okay. Then there's pleasure. Is it good, bad, irrelevant?
Aristotle argues against those who say pleasure is always bad. He defines pleasure as the unimpeded activity of our faculties, something that completes an activity like the bloom on youth.
So pleasure accompanies good activities.
Yes, and the best activities have the best pleasures. The pleasure proper to an activity enhances it. He thinks the highest pleasure comes from contemplation, the activity of the intellect. Bodily pleasures are fine in moderation, but can become problematic if pursued excessively, partly because humans naturally need variety and change.
That leads nicely into books 8 to 9 on friendship, philia. This seems like a huge topic for him.
It really is. 2 whole books. He saw friendship as absolutely essential for eudaimonia and for a healthy society. You can't truly flourish without friends.
What exactly is friendship for him?
It's mutual goodwill between 2 people where both are aware of the goodwill. He famously distinguishes 3 types based on the reason for the friendship.
Guitar.
Friendships of utility, based on mutual usefulness. Friendships of pleasure, based on shared enjoyment, and friendships of virtue, based on mutual respect and admiration for each other's good character.
And the virtue friendship is the best one.
By far. It's the most stable, the most complete, Because it's based on loving the friend for who they are. Utility and pleasure friendships are more easily dissolved when the usefulness or pleasure disappears. True friends wish good for each other for the other's own sake. He also emphasizes the need to spend time together and the challenges of friendships between unequals.
Right. And then Book X brings it all back together, revisiting happiness and talking about education and law.
Yes, he circles back to eudaimonia as the ultimate aim, reaffirming it's an activity desirable in itself, not mere amusement. And then he makes his big claim. The most perfect happiness, the highest form of eudaimonia, is found in philosophical contemplation, the churia.
Why contemplate?
Because it's the activity, the highest part of us, the intellect. It's the most continuous, the most self-sufficient, the most pleasant, and it's closest to the activity of the divine. He concludes that the life according to reason is the best and happiest life.
But not everyone can just sit around contemplating all day.
Exactly, and that's why the end of the Ethics stresses the importance of good habits formed through education from youth, and the crucial role of good laws and a well-structured community, the polis, in fostering virtue among citizens. Ethical theory isn't enough. It needs practical application through societal structures.
Which leads directly into his politics.
Precisely. To create the conditions for widespread flourishing, you need to study politics and figure out how to design the best laws and institutions.
Wow. Okay. That's a really rich picture. So, summing up the deep dive into the Nicomachean Ethics, it's all about aiming for eudaimonia, this deep flourishing achieved by cultivating virtues, both moral finding, that mean or balance, and intellectual, especially practical wisdom. Friendship is vital, and the highest happiness might lie in contemplation, but all this needs the support of good habits, education, and laws.
That's a great summary. It's a framework for character development, for making intentional choices, for seeking a meaningful life that's, more than just chasing pleasure or success.
It really does feel timeless in many ways. Even though the context is ancient Greece, these ideas about character, purpose, finding balance, they give you so much to chew on today. So for you listening, what are the big takeaways?
Well, maybe the most provocative thought is this. Aristotle insists that eudaimonia, true flourishing, comes from activity in accordance with virtue. It's not passive. In our world, which often values ease or external validation or maybe even just feeling good, how does this ancient focus on disciplined character building and rational activity strike you? What aspects of your life, maybe your goals or habits, could be re-examined through this Aristotelian lens of virtue as the path to flourishing?
That's a powerful question to leave us with. Thank you for joining us on this deep dive into Aristotle's Nicomachean Ethics, guided by the excellent overview on Wikipedia. We hope it's given you a useful handle on these profound ideas. If there's another topic or source you'd like us to tackle, do let us know. Until our next deep dive, keep thinking, keep questioning, and keep exploring. Think for a moment about creatures that have patrolled our skies since before the dinosaurs. Tiny aerial predators with iridescent wings catching the sunlight. We're diving deep into the fascinating world of dragonflies today.
That's right. These insects, belonging to the infraorder Anisoptera, are a truly ancient and remarkably diverse group. Their history stretches back hundreds of millions of years.
And we've gathered a wealth of information, from their evolutionary roots all the way to their surprising connections to human culture across the globe.
Yeah, there's a lot there.
Our mission in this deep dive to uncover the most captivating aspects of these aerial masters, delivering those aha moments that leave you feeling truly well-informed. Okay, let's start with the basics. What exactly is a dragonfly?
Simply put, a dragonfly is a flying insect belonging to the Anisoptera. We know of about 3,000 species living today, give or take.
3,000. Wow.
And most of those thrive in warm tropical climates. Sadly, their populations are increasingly threatened by the loss of the wetland habitats they depend on.
Right. And you certainly can't miss them when you see one. They have that distinctive elongated body, 2 pairs of strong, often colorful, transparent wings.
Sometimes colored, yeah.
And those enormous, multifaceted eyes that seem to see everything.
Precisely. And those brilliant colors aren't like, paint pigments. They're a result of what we call structural coloration.
Structural coloration.
Yeah, think of it like a prism. The microscopic structure of their wing surfaces refracts light, creating those vibrant, often metallic hues. And those compound eyes Incredible. They're like having thousands of tiny lenses working together.
Thousands.
Some species have nearly 24,000 of these individual units called ommatidia in each eye.
24,000. So it's not just panoramic vision, it's like having super detailed information coming in from almost every angle simultaneously.
Exactly, almost 360 degrees.
Now, dragonflies are often confused with damselflies. They look kind of similar. What's the key difference?
Well, they are close cousins, yeah, both within the order Odonata. But the main differences lie in their body shape and how they hold their wings when they rest.
Okay.
Dragonflies tend to be more robust, a heavier build, and when they land, they typically hold their wings spread out flat, horizontally. They're also generally more powerful and agile in flight.
Right.
Damselflies, on the other hand, are usually more slender, a lighter build, and most species fold their wings neatly along their abdomen when they rest. Their flight is often weaker, maybe more of a delicate flutter.
So if it lands with its wings open flat, it's likely a dragonfly. Makes sense.
Yeah.
Now, you mentioned they're ancient. Just how ancient are we talking?
We're talking deep time, really deep. Fossils of dragonfly-like insects, often called griffinflies or Meganosoptera, date back to about 325 million years ago.
Wow.
That's the Upper Carboniferous period. These weren't technically true dragonflies as we know them, but some were truly colossal.
How big?
Some had wingspans up to 750 millimeters. That's about 30 inches. Imagine that fluttering past.
30 inches. That's enormous, like a bird. So when did the true dragonflies, the ones we'd recognize today, actually appear?
True dragonflies, within the infraorder Anisoptera, first evolved during the early Jurassic period. That's around the Torreson age.
Okay, so still dinosaur times, basically.
Oh, yeah. And they still retain some characteristics of their really ancient relatives in the Paleoptera group, meaning ancient winged. Most notably, the inability to fold their wings flat over their back like, say, a beetle can, though some have evolved other ways to rest their wings.
Right.
They share a common ancestry with those giant griffinflies, the Meganosoptera, and another early group called Protanosoptera.
It's just mind-boggling to think of that lineage stretching back so far.
Yeah.
And the name Anisoptera itself sounds quite scientific. What does it mean?
It comes from Greek. Anisos, meaning unequal, and erteron, meaning wing.
Unequal wing.
Exactly. It's a direct reference to the fact that a dragonfly's hind wings are noticeably broader than their forewings. A simple but descriptive name.
Right, you can definitely see that difference. And are there any major families of modern dragonflies that are particularly noteworthy? Ones people might see?
Yes, definitely. While scientists are still, refining the exact relationships between all the families,
Sure.
some of the main ones you might hear about include the Echinidae, or hawkers. They're often large, powerful flyers that patrol territories.
Hawkers, okay.
Then there are the Gomphidae, the clubtails, often found near flowing water,
Yeah.
and they have a sort of distinctive thickened shape at the end of their abdomen.
Oh, the clubtail.
Right. The Libelulidae, or skimmers, are a really diverse and commonly seen group. Lots of different types in there.
Skimmers, I think I've seen those.
Probably. And the Cordulidae, the emeralds, often have these striking metallic green bodies, beautiful insects. Each family has its own sort of set of characteristics and ecological preferences,
Okay, so we've got a picture of what they are.
Yeah.
And when they appeared. Now, where in the world can you actually find these incredible insects? Are they everywhere?
Pretty much everywhere except Antarctica. They're really widespread.
Really?
Yeah, interestingly, while damselflies often have quite specific and sometimes limited ranges, some dragonfly species are surprisingly cosmopolitan.
Like which ones?
Well, take the blue-eyed darner, Rhianoschna multicolor. You find that right across North and Central America. Or dragonflies in the Anax genus, the emperors. They span the Americas, Europe, Central Asia, North Africa, the Middle East.
That's a truly global presence for some of them then.
Absolutely. And then there's the globe skimmer, Pantala flavescens. This species is likely the most widespread dragonfly on the planet.
The most widespread.
Possibly, yeah. Found on every continent in the warmer regions. It's an incredible feat of dispersal.
Wow.
However, while these few are really cosmopolitan, the vast majority of the 3,000 or so species are found in the tropics. You get fewer species as you move into temperate zones.
So warmer climates generally mean more dragonfly diversity. Is that the rule?
That's the general trend, yes. But what's truly remarkable is how some dragonflies have adapted to survive in really challenging environments.
Like what?
Well, certain species in the Libelulidae and Echinidae families can tolerate the really high temperatures you find in desert pools.
Desert pools, wow.
And they can also be found at impressive altitudes. One species of Echna has been recorded as high as 3,700 meters. That's over 12,000 feet in the Pamir Mountains.
That's incredibly high. What about the cold? Do they manage in the more frigid parts of the world?
They definitely become less common as you head towards the poles. They aren't native to Iceland, for instance, though the occasional one might get blown in by the wind.
Ah.
And in places like Kamchatka, in far eastern Russia, you'll only find a small handful of species, likely because the lakes are just too cold for most.
Right.
However, the tree-line emerald, Somatochlora arctica, holds the distinction of being the most northerly dragonfly. It actually lives within the Arctic Circle in northern Alaska.
Inside the Arctic Circle.
Yeah.
Talk about a survivor.
It really shows their adaptability, doesn't it? Even though extreme cold does limit their overall distribution.
Okay, so we know they're masters of flight and have incredible vision, but what about the rest of their physical structure?
Yeah.
What are the key components of a dragonfly's anatomy?
Well, like all insects, they have three main body segments: the head, the thorax, and the abdomen, all encased in that protective chitinous exoskeleton.
Huh?
The head, as we've discussed, is dominated by those huge compound eyes and has a very short antenna. They also have three simple eyes called ocelli, usually on top.
Three simple eyes, too.
Yep. And their mouth parts are designed for predation-strong, toothed jaws and a lower lip, the labrum, that can shoot out incredibly fast to snatch prey.
Wow.
And interestingly, Odonata, that's dragonflies and damselflies, have this unique internal arrestor system. It basically helps lock their head in place. Really useful for stability when they're eating or flying in tandem during mating.
A built-in stabilization system.
Yeah.
That's ingenious. What about the thorax, the middle section?
The thorax is actually made up of three segments fused together. Creates a really strong, rigid box that supports those powerful wing muscles.
Right, for the flight.
Exactly. It's where the two pairs of long, membranous wings attach. And remember, the hind wings are broader than the forewings. That's the anisoptera part. The wings have that intricate network of veins.
Yeah, you can really see the veins.
And those veins aren't just structural supports. They also carry hemolymph, which is kind of like their blood. It helps with expanding the wings after they emerge and keeping them rigid. You'll also notice a small notch on the leading edge of each wing called the node.
The node.
Yeah, it adds flexibility during flight, lets the wing twist a bit for control, and then there are their legs. They might seem a bit delicate for such a robust creature, right?
Yes, they don't look like they spend much time walking on the ground.
And they really don't. Their legs are primarily adapted for catching and holding prey in midair. They form a sort of basket. They also use them for perching, climbing on vegetation, and even grooming those amazing eyes. Male dragonflies have these specialized spines on their front legs that act like a little eye brush.
An eye brush. That's brilliant. Nature truly has thought of everything.
Yeah.
And that long segmented abdomen, what's its main role?
Well, it typically consists of 10 segments and houses the digestive tract and the reproductive organs towards the tip. In males, things get a bit complicated.
How so?
The actual sperm is produced near the back in segment 9, but before mating, they have to transfer it to specialized structures, the secondary genitalia, which are located way up front on segments 2 and 3.
That seems awkward.
It leads to that unique mating posture we see. Females have their genital opening on the 8th segment, and depending on the family, this might be accompanied by a simple plate or a more complex knife-like ovipositor for laying eggs inside plants.
Okay, so that's the adult dragonfly. But they start their lives in the water as nymphs, right? Or naiads. What are they like?
Right, nymphs or naiads. You hear both terms. They come in a variety of forms depending on the species and their lifestyle. Some are built for clinging onto rocks in fast water. Others are designed for sprawling on the bottom mud. Some hide amongst vegetation, and others actively burrow in the sediment.
Lots of different strategies.
Exactly. The very first stage, right after hatching, is a short-lived, relatively inactive phase called the prolarva. It doesn't last long before it molts into the more recognizable nymph form. They share the basic body plan: head, thorax, abdomen, but obviously lack wings and functional reproductive organs.
They hunt too, right?
Oh, absolutely.
Yeah.
A key feature is their extendable labium, often called a mask.
The mask.
Yeah, it's this hinged jaw-like structure, usually folded under the head. It's armed with sharp hooks or teeth, and they can shoot it out incredibly fast, like lightning fast, to grab unsuspecting prey.
Sounds like a fearsome little predator lurking beneath the surface. Yeah. And how do they breathe underwater? They have gills.
They do, but they're internal. They have gills located inside their abdomen within a specialized chamber called the branchial chamber.
Inside the abdomen.
Yeah, they pump water in and out through an opening at the very tip of their abdomen to extract oxygen. Interestingly, some clubtail nymphs, the ones that burrow in mud, have evolved a kind of snorkel-like tube at the end of their abdomen. They can stick that up into cleaner water above the silt to breathe.
A built-in snorkel. Clever.
And if they need to make a quick escape, dragonfly nymphs can forcefully expel a jet of water from that abdominal chamber. Gives them a surprising burst of speed, a kind of jet propulsion.
Built-in escape jets. Amazing. We've talked about the vibrant colors of the adults. What about the nymphs? Are they as colorful?
Not usually, no. Dragonfly nymphs are typically masters of camouflage. They blend in really well with their aquatic environment, usually in muted shades of brown, green, and gray.
Makes sense. Helps them hide.
Exactly. Helps them avoid detection by their own predators, like fish or bigger nymphs, and also makes them more effective ambush hunters themselves.
Right, sneak attacks. Okay, let's explore how these creatures interact with their world. What's their ecological role? What do they do out there?
Ecologically, dragonflies are pretty high up the food chain, you could say. They're apex predators in their respective ecosystems, both as aquatic nymphs and as flying adults.
Apex predators. Even the little ones.
In their world, yeah. Nymphs feed on a wide range of freshwater invertebrates, mosquito larvae, mayfly nymphs, stuff like that. The larger ones are perfectly capable of taking down tadpoles and even small fish.
Wow.
There's even one peculiar species, Phenogomphus militaris, whose nymphs might actually be parasitic, living on the gills of freshwater mussels for a time.
Parasitic? That's different.
It is unusual. Adult dragonflies, as we know, are aerial hunters. They rely on that exceptional vision and incredible flight agility to hunt and capture other flying insects right out of the air.
So, from their larval stage to adulthood, they're always on the prowl. What about finding a mate? I know their mating rituals are quite elaborate.
They are indeed. Dragonflies have a fascinatingly complex mating system. It involves indirect sperm transfer. Remember the male moving sperm to his secondary genitalia?
Right, the awkward bit.
Exactly. Females can also store sperm, sometimes from multiple males, leading to delayed fertilization and what we call sperm competition.
Sperm competition.
Yeah, where the sperm from different males competes to fertilize the eggs. It gets quite complex. Males are often highly territorial as well. They'll defend areas near water that offer good habitat for the nymphs to develop and for females to lay their eggs.
Defending their turf.
Definitely. And sometimes you might see big groups of adult dragonflies forming feeding swarms, especially when there's a hatch of other insects like flying ants or termites. Easy picking.
A fierce aerial contest for both food and mates. What kinds of habitats do they prefer for breeding and living? Are they picky?
Their habitat preferences are actually quite diverse. Some species are specialists, really favoring flowing waters like streams and rivers. Others thrive in still waters, ponds, lakes, marshes.
So it varies a lot.
It does. For example, you'll often find clubtails, the Gomphidae, near running water, whereas skimmers, the Libellulidae, tend to prefer still water environments. Some species are even adapted to the tough conditions of temporary pools, the ones that dry up sometimes. They have to tolerate big swings in water level and temperature.
Tough little critters.
Yeah. And vegetation is crucial too. Adults need places to perch, often emergent plants sticking out of the water. And different species have specific requirements for where females lay their eggs, some on submerged plants, some on floating leaves, some in the stems.
Okay.
Some species are particularly tied to specific plants, like the greenhawker, Echeneveretus in Europe. It's closely associated with swamps containing water soldier plants. Even water chemistry matters, nutrient levels, pH. It can all determine which dragonfly species can successfully live and reproduce there.
It's amazing how finely attuned they are to their specific environmental conditions. We often hear about male dragonflies being territorial. What does that behavior actually look like? Are they chasing each other all the time?
Pretty much, yeah, especially the males. Many species exhibit strong territorial behavior. They'll defend a chosen area against rivals, sometimes other males of their own species, sometimes males of different dragonfly species, or even other insects that wander into their prime hunting spot.
What makes a spot worth defending?
Could be a favorite perch that gives a really good view for spotting prey passing by. Or it could be a breeding territory that has just the right features for egg laying, like sunny, shallow water, the right kind of plants.
And how big are these territories?
It varies. Depends on the quality of the territory, the time of day, how many competitors are around. Some species even seem to use specific landmarks, a certain rock, a prominent plant, to help define the boundaries of their territory.
So they're like tiny aerial landlords staking their claim. And how do they signal to other dragonflies, hey, this spot is taken?
They use a variety of signals. Some species have bright, conspicuous colors maybe on their face, abdomen, legs, or wings that they flash at intruders.
Like a warning sign.
Exactly. For instance, a male common white-tailed dragonfly, which has this bright white abdomen, will often fly towards a rival holding that abdomen high. It's a clear visual warning. Others engage in these dramatic aerial displays, fast chases, dives, complex maneuvers to assert dominance and drive off competitors.
Yeah.
Basically, yeah. And in many species, females seem to prefer, or maybe are only receptive to, mating with the male that successfully holds a territory. So that adds another layer of importance to defending that space.
Sounds like there's a lot of aerial drama playing out around ponds and streams. Is there any conflict between male and female dragonflies beyond just territory control, like harassment?
Yes. Unfortunately, sometimes females can experience significant harassment from persistent males. It can really interfere with their ability to just feed or rest.
It sounds stressful.
It can be. And in some species where males and females look quite different, females have actually evolved multiple forms. Some female forms mimic the appearance of males.
Really, why?
It's thought that this might be a way to avoid unwanted male attention, kind of blend in. There are even documented cases of females feigning death, just abruptly falling out of the air to escape a particularly persistent suitor.
Faking death. That's extreme.
It shows the pressure they can be under. But conversely, adult dragonflies don't just randomly wander around either. They often show strong site fidelity, returning to the same foraging areas day after day, sometimes for months. And remarkably, some species have foraging ranges that are thousands of times larger than the ponds or streams where they actually hatched.
That's an incredible commute. Let's get back to the intricate mating process. You mentioned the secondary genitalia and the wheel position. How does the actual act of reproduction take place?
Right. It's a fascinating and highly choreographed event. First, the male needs to attract a female into his defended territory, often while constantly battling off other males.
Busy guy.
Very. When a male is ready to mate, he first has to transfer that packet of sperm from the tip of his abdomen up to his secondary genitalia near the front.
Okay, the prep work.
Then he has to grab the female, usually by her head or the back of her thorax, using those specialized claspers at the end of his abdomen. The shape of these claspers is often unique to each species, like a lock and key, helping ensure he's mating with the correct female.
Species-specific claspers. Interesting.
Yeah. The pair then flies connected, in tandem, with the male usually leading. They might perch together like that too. Then the female has to bend her abdomen forward to actually connect with the male's secondary genitalia and pick up the sperm. That's when they form that iconic heart-shaped or wheel-like posture.
That heart shape is such a recognizable image, and I've often seen them flying around still connected, even during egg laying sometimes. Why is that?
That's a behavior called mate guarding. By remaining physically attached to the female after transferring sperm, the male is essentially trying to prevent other males from mating with her right away.
Preventing that sperm competition we talked about.
Exactly. He wants to ensure his sperm is the one that fertilizes her eggs. Females, remember, have that specialized sperm storage organ, the spermatheca. Sperm from multiple males can be stored there, and it can stay viable for quite a while, at least 12 days in some studied species.
There's a real competition.
It is. And males even have specialized structures on their penis, sometimes scoop-like or brush-like, that they actually use to try and displace or remove sperm from previous matings before they deposit their own.
Wow, that's intense.
It is. Flying in tandem also seems to benefit the female, though. The male's flight can help support her, conserving her energy for the demanding task of egg laying. And in some species, if the female needs to go underwater to lay eggs, the male might stay attached and help pull her back out.
Talk about dedication. So after all that, how and where do the females actually deposit their eggs?
There are two main methods, and it largely depends on the dragonfly family. In families like the Echinidae, hawkers, and Petaluridae, the female has a sharp, blade-like ovipositor.
The egg-laying tool.
Right. She uses this to cut little slits into the stems or leaves of aquatic plants, or sometimes even plants near the water's edge, and then she carefully deposits her eggs inside those slits.
Protected inside the plant.
Exactly. In the other major families, like Gomphidae, clubtails, Macromidae, Cordulidae, emeralds, and Libilidae skimmers, the female typically lays her eggs differently. She'll often fly low over the water, repeatedly tapping the tip of her abdomen onto the surface. This washes the eggs off into the water. Or she might land briefly and place them directly onto floating or emergent vegetation.
Just dropping them in or sticking them on.
Pretty much. And interestingly, in a few cases, eggs are laid on plants that are actually above the waterline. Their development gets delayed until the plant eventually dies back or falls into the water, and the eggs finally get submerged.
Delayed development, a clever strategy for habitats with fluctuating water levels, perhaps.
Could be, yeah, a way to hedge their bets.
We've touched on the nymph stage quite a bit. Can you give us an overview of the complete dragonfly life cycle, start to finish?
Certainly. As we mentioned earlier, dragonflies undergo incomplete metamorphosis. That means no pupal stage like a butterfly.
Right, egg, nymph, adult.
Basically, yes. The eggs, which vary a lot in shape and size and can be laid in clutches of up to 1,500, typically hatch into those aquatic nymphs or naiads, usually within about a week or so, depending on temperature.
Okay.
These nymphs then go through a series of molts, shedding their exoskeleton as they grow. It can be anywhere from 6 to 15 molts, depending on the species and conditions.
15 molts, wow.
Yeah, and this nymphal stage can last anywhere from a few months to several years. In fact, for most dragonflies, the vast majority of their life is spent underwater as a nymph.
Years underwater.
Absolutely. During this time, they use that remarkable extendable labium, the mask, to hunt all sorts of prey, mosquito larvae, other insect larvae, worms, tadpoles, small fish for the bigger ones. They breathe through those internal rectal gills and can use that jet propulsion for quick escapes. And intriguingly, as we noted, some nymph species, like Antipodophlebia asthenes in Australia, have even been observed venturing out onto land at night to hunt small arthropods near the water's edge.
Land-based dragonfly nymphs. That's still amazing. What happens when they're finally ready to become adults? How does that transformation work?
When the nymph reaches its final developmental stage, its final instar, it stops feeding and finds a suitable spot to emerge. Usually, it climbs out of the water onto an emergent plant stem, a reed, a rock, or even the bank, typically under the cover of darkness, maybe at night or very early morning.
Safer then.
Probably less risk from predators like birds. It will then remain still for a while, often with its head out of the water as its respiratory system adapts to breathing air. Once it's ready, it anchors itself really firmly with its claws, and its exoskeleton splits open right behind the head, along the thorax.
The skin splits.
Yeah. Then the adult dragonfly slowly and laboriously begins to wiggle and pull itself out of its old nymph skin, which we call the exuvia. It often arches backwards dramatically during this process, letting its new, soft exoskeleton start to harden in the air.
Must be exhausting.
Looks it. Finally, it will curl back upwards, pull the rest of its abdomen free, and complete the emergence. Then it needs to inflate its body by swallowing air and pump hemolymph into its crumpled wings to expand them fully. This whole process can take a few hours.
And then it flies away.
Not immediately.
Hey.
The newly emerged adult, called a teneral, is very pale and soft-bodied. Its wings are fragile. It needs to rest and allow its exoskeleton to harden completely, which can take several hours or even a day or two before it takes its first proper flight.
So that familiar, agile dragonfly we see darting around was once that very different-looking creature clinging to a reed, going through this incredible, vulnerable transformation.
Exactly. It's a really critical stage in their life. And in temperate regions, you often see distinct patterns of emergence. Some species, we call them spring species, tend to emerge in a highly synchronized burst over just a few days.
All at once.
Pretty much. While others, the summer species, emerge more gradually over a longer period, maybe weeks or even months.
Okay.
So you might see a particular spring species become very common for a short time and then seem to disappear until the following year, whereas summer species might be present throughout the warmer months as new adults keep emerging.
Interesting seasonal strategies. Now, thinking about the adults we see flying around, are there typically more male or female dragonflies in a given area? Is the ratio even?
That's a good question. Often what you observe at breeding habitats, ponds, streams, is a heavily male-biased sex ratio. Way more males hanging around than females.
Really? Why is that?
Well, the males are there setting up territories, waiting for females, competing. Females might only visit these specific breeding sites briefly to mate and lay eggs, spending more time foraging elsewhere.
Trying to avoid the crowds.
Possibly, yeah, and avoiding that harassment we talk about. For example, in the case of the endangered Heinz emerald dragonfly, studies found males tend to congregate in the open wetland breeding habitats, while females often spend more time in adjacent drier meadows and maybe less optimal areas, only popping into the wetlands when they need to breed.
Right.
These unwanted mating attempts by multiple males can be really energetically costly for females. Takes time and resources away from feeding and just surviving.
So navigating those social dynamics is a real part of the challenge for female dragonflies. Let's switch gears and talk more about their remarkable flight. They're just like tiny, incredibly maneuverable aircraft.
They truly are. Dragonflies are exceptionally powerful and agile flyers. They're capable of migrating huge distances, even across oceans in some cases.
Those oceans.
Yeah, the globe skimmer is famous for it. And they can move in pretty much any direction, up, down, forward, backward, left, right, with incredible speed and precision.
How do they do that?
They employ 4 primary flight styles. There's counterstroking, where the forewings and hindwings beat out of phase. This allows for hovering and very slow flight.
Hovering like a helicopter.
Kind of, yeah. Then there's phase stroking, where the hindwings beat just slightly ahead of the forewings. That's for faster, more efficient forward flight.
Okay.
Synchronized stroking is when all 4 wings beat together. This gives them rapid acceleration and allows for quick directional changes.
It's a fast gear.
Right. And finally, gliding, where they just hold their wings still to conserve energy, often using updrafts.
4 distinct modes.
Yeah.
And unlike many other insects, their wing muscles are attached directly to the wings, aren't they?
Precisely. They have what's called direct flight muscles. This gives them very fine control over each wing independently and contributes to that high power-to-weight ratio. It enables impressive acceleration both linear and in sharp turns, especially when they're chasing prey or escaping predators.
And the wings themselves are complex.
Very. They generate lift using multiple aerodynamic principles. There's the classic lift from the wing's airfoil shape, but they also use things like supercritical lift at high angles of attack, and they generate and shed little whirlpools of air, vortices, from their wingtips, which enhances lift and stability. Their wings are also incredibly dynamic. They flex and twist with each beat to optimize airflow and thrust. It's very sophisticated.
And they can reach some pretty impressive speeds, I believe.
Yeah, while some older claims of, ridiculously high speeds are probably exaggerated.
Right.
Reliable measurements indicate that large hawker dragonflies can achieve maximum speeds of around 36 to 54 kilometers per hour. That's maybe 22 to 34 miles per hour in short bursts. A more typical cruising speed is probably around 16 kilometers per hour or 10 miles per hour.
Still pretty quick.
It is, especially considering their maneuverability. What's maybe even more remarkable is the distance they can cover relative to their body size in just 1 second. Some can travel up to 100 of their own body lengths forward and even manage about 3 body lengths backwards.
Flying backwards, too. That's incredible. I also came across something called motion camouflage in my reading. What's that all about? Sounds like something out of science fiction.
It does sound cool, doesn't it? This is a fascinating hunting and territorial defense tactic. It's been particularly well studied in male Australian emperor dragonflies during those high-speed territorial chases.
How does it work?
Basically, the attacking dragonfly adjusts its flight path in such a way that, from the rival's perspective, the attacker appears to remain stationary in its field of vision.
Stationary, while flying fast.
Yeah. By flying along a specific trajectory that keeps a constant line of sight between the rival and some distant fixed point, the attacker looms larger as it gets closer, but it doesn't seem to move side to side. This makes it much harder for the rival to detect its approach vector and take evasive action.
That's like a real-life stealth maneuver. Amazing. What about their body temperature? Being insects, they're cold-blooded, right?
Wow.
So how do they keep those flight muscles working effectively, especially on cooler days?
Right, they're ectothermic, meaning they rely on external sources of heat. But they're not just passive victims of the temperature, they actively regulate their body temperature, especially the thorax where the flight muscles are.
How do they do that?
They use a range of behavioral strategies. Basking is a big one. They'll perch in the sun, often orienting their bodies to maximize exposure. You might see them perched vertically in the cooler morning hours, then switching to horizontal perches later when the sun is higher and hotter.
Okay, sunbathing.
Exactly. Some larger species also use wing whirring. They vibrate their wings rapidly without actually flying, which generates heat in the flight muscles through friction.
Shivering almost.
Kind of, yeah. They'll also actively choose sunny or shady perches depending on whether they need to warm up or cool down. Some species have dark patches on their wings, and it's thought these might help absorb solar radiation or maybe even provide localized shade to their bodies.
Clever.
And when they get too hot, you might see them adopting the obelisk posture.
Obelisk posture.
Yeah, they'll raise their abdomen and point it directly towards the sun. This minimizes the surface area exposed to direct solar radiation, helping them cool down. They might also briefly skim the surface of the water, touching it with their abdomen, which probably helps with both cooling and rehydration.
So they're quite active in managing their temperature, not just at the mercy of the environment. We know they're formidable hunters. What exactly do adult dragonflies eat, and just how good are they at catching their prey?
Adult dragonflies are almost exclusively carnivorous, yeah. They're aerial predators relying on that amazing eyesight and flight skill. They eat a huge variety of flying insects, anything from tiny midges and mosquitoes.
Good, eat the mosquitoes.
Absolutely, all the way up to butterflies, moths, damselflies, and even other smaller dragonflies.
Apples too.
Sometimes, yes. If it flies and it's smaller, it's potentially food. Larger prey is typically subdued with a quick bite to the head, then carried to a perch. They'll usually discard the wings and then eat the body, often starting with the head. And they need to eat a lot. A dragonfly can consume a significant amount of food, sometimes up to a fifth of its own body weight in a single day.
A fifth of their body weight.
Wow. And they are incredibly efficient hunters. Studies have estimated their success rate in capturing prey they target can be as high as 95%.
95%. That's an astonishingly high success rate for any predator.
It really is. Very few misses.
And the dragonfly nymphs. What's on their underwater menu? Are they as successful?
Just like their adult counterparts, dragonfly nymphs are voracious predators in their own world. They feed on pretty much most living things smaller than themselves that they encounter underwater.
Like what specifically?
Their diet typically includes things like bloodworms, other insect larvae like mosquito or mayfly larvae, small crustaceans, worms. But larger nymphs will definitely prey on tadpoles and even small fish if they can catch them.
So, important predators in freshwater ecosystems.
Absolutely crucial. And remember those odd ones. Some nymph species, particularly those in temporary water bodies, might even crawl out of the water at night to hunt small terrestrial arthropods near the edge. And some big annex nymphs have even been seen leaping out of the water to grab small frogs sitting nearby.
Leaping out for frogs. Okay. From the air to the water's edge, they're persistent hunters throughout their lives. And that incredible eyesight must be absolutely crucial to their hunting success, both nymph and adult.
Oh, absolutely central to it. Dragonfly vision is truly remarkable. They can perceive movement much, much faster than humans can. We process maybe 60 images per second. They're up around 200.
Wow, the world must look like slow motion to them.
Effectively, yeah. It allows them to track fast-moving prey with incredible precision. Plus, they have that nearly 360-degree field of vision. And an astounding percentage of their brain power, some estimates say nearly 80%, is dedicated purely to processing visual information.
80% of their brain for sight. It's really no wonder they're such effective hunters. But with all their predatory prowess, they must also face threats from other animals, right? What eats dragonflies?
Oh, definitely. Despite their speed and agility, they are absolutely part of the food web. In the air, they get preyed upon by various birds. Fast birds of prey, like kestrels, merlins, and hobbies, are specialized hunters of dragonflies.
Birds fast enough to catch them.
Right. Other aerial predators include things like nighthawks, swifts, flycatchers, and swallows. They'll snatch them out of the air, too. Even some species of wasps will hunt dragonflies, paralyze them, and carry them back to their nests to feed their own larvae.
Wow, wasps, too. What about the nymphs?
In their aquatic nymph stage, they're vulnerable to a different set of predators. Ducks and herons will eat them, newts, frogs, lots of types of fish. Even some water spiders will prey on dragonfly nymphs.
Lots of dangers underwater.
For sure. And there's that fascinating example of the Amur falcons. They migrate over the Indian Ocean at the same time as vast numbers of globe skimmal dragonflies are also migrating. And it's widely believed that the falcons rely heavily on catching these migrating dragonflies as a crucial food source during their incredibly long overseas journey.
Eating dragonflies mid-migration over the ocean, that's amazing. Yeah. So they're both hunters and hunted. What about smaller threats like parasites? Do dragonflies have issues with those?
Yes, they definitely do. Dragonflies are susceptible to various parasites, both as nymphs and adults. Water mites, tiny little arachnids, can attach themselves. Heavy infestations can sometimes kill small nymphs, and you often see the bright red mites attached to adult dragonflies too.
Okay, mites. Anything else?
There are gregarine protozoa. These are single-celled organisms that can infect their gut, potentially causing blockages or leading to secondary infections. And then there are trematode flatworms or flukes.
Flukes, like the ones humans can get.
Related kinds, yeah. They have really complex life cycles, often involves a freshwater snail as the first host, then dragonfly nymph acts as a second intermediate host, the fluke develops inside the nymph, and then the final host, often a vertebrate, like a frog, or maybe a bird that eats the dragonfly nymph or the emerging adult, gets infected when it eats the dragonfly.
Wow, a whole microscopic world of parasites interacting with these aerial predators. It's a good reminder of how interconnected everything is in an ecosystem.
Absolutely.
Now, shifting our focus a bit, how are dragonflies faring in our modern human-dominated world? Are there conservation concerns? Because you mentioned habitat loss earlier.
Sadly, yes, there are significant and growing conservation concerns for many dragonfly species worldwide, while, a lot of research has focused on the dragonflies of North America and Europe.
Right, where most scientists are.
Exactly, but the vast majority of species actually live in tropical regions, and many of these remain poorly studied. With the ongoing and accelerating destruction of rainforest habitats, many of these lesser-known tropical species are facing a really high risk of extinction, sometimes even before we properly understand them.
That's tragic. What's the main driver of their decline?
The primary driver globally is habitat loss and degradation. That comes largely from deforestation, which leads to streams and pools drying up or getting choked with silt from erosion.
Okay.
Other major threats include the damming and diversion of rivers, which changes water flow regimes. The drainage of wetlands for agriculture or urban development is huge. Pollution is another big one. Pesticides, industrial runoff, sewage, it all impacts the water quality they depend on. And finally, the introduction of invasive alien species like certain fish or crayfish can devastate nymph populations.
That paints a really concerning picture.
Mhm.
Are there active efforts being made to protect them? What can be done?
There are ongoing conservation efforts, yes. The International Union for Conservation of Nature, IUCN, has a specialist group focused on dragonflies and damselflies, and they highlight the conservation needs. Strategies generally focus on protecting and restoring their habitats.
Like setting up reserves.
Exactly. Establishing and effectively managing protected areas that include important dragonfly habitats, wetlands, riversides. Restoring degraded wetlands and the vegetation along rivers is also key. Promoting more environmentally friendly practices in forestry, agriculture, and industry to minimize habitat destruction and pollution is crucial too. And of course, public education plays a big role raising awareness about why these insects matter and the importance of conserving biodiversity in general.
Are we seeing actual declines?
Yes, definitely. We're seeing concerning population declines documented in various regions. For example, in Japan, a huge percentage of historically important wetland habitats have been lost, and that's directly impacted their dragonfly populations. Africa is also recognized as a really crucial continent for dragonfly conservation because it has high diversity, but the threats to its natural habitats are increasing rapidly.
It sounds like they're quite vulnerable.
They can be. Their relatively long larval development times, sometimes years underwater, and often quite low adult population densities, can make them particularly susceptible to environmental disturbances. Even things like collisions with vehicles can be a problem in areas where roads pass close to wetlands.
Right. It's a stark reminder that even these ancient and seemingly resilient creatures are facing really serious modern challenges. I also read something fascinating and kind of weird about dragonflies being strangely attracted to shiny surfaces, like cars or gravestones. What's that about?
Yes, that's a documented phenomenon. Dragonflies, especially females looking for places to lay eggs, have a strong innate attraction to horizontally polarized light.
Polarized light.
Yeah, the light that reflects off the surface of calm water is strongly polarized horizontally. It's a key visual cue for them to find suitable breeding habitats.
Ah, so they're looking for water.
Exactly. But unfortunately, many artificial shiny surfaces, things like polished black gravestones, solar panels, dark-colored car roofs, even some types of asphalt also reflect light in a way that's highly polarized horizontally.
So the dragonflies mistake them for water.
Precisely. This can lead to them congregating around these surfaces, sometimes in large numbers, and even attempting to lay eggs on them, which is obviously futile and wastes their reproductive energy.
Does that have a big impact?
It might seem minor, but in areas with, say, large arrays of solar panels or maybe cemeteries with lots of polished headstones located near natural dragonfly habitats, it could potentially impact local populations by drawing females away from actual water bodies and causing them to waste eggs. Researchers are looking into ways to make these surfaces less attractive to them, maybe by changing the surface properties.
An unfortunate case of our modern world confusing these ancient instincts. Now, given their long history and striking appearance, Dragonflies must have found their way into human culture across different times and places, right? They must have symbolic meaning.
Oh, absolutely. They hold a really wide variety of symbolic meanings around the world. It varies quite a bit.
Like what?
Well, in ancient Egypt, a faience amulet shaped like a dragonfly was discovered. It's speculated it might have symbolized pure water or maybe transformation emergence.
Okay.
For the Navajo people in North America, the dragonfly is a powerful symbol of pure water, and you see it frequently as a decorative motif in their traditional art, like jewelry and pottery.
Pure water again.
Yeah, seems to be a common link. In Japan, the dragonfly, or tombo, is a very important seasonal symbol, strongly associated with autumn, but it also represents concepts like rebirth, courage, strength, and happiness.
Lots of positive meanings there.
Definitely. They're a common subject in Japanese art and literature, especially in haiku poetry. There's even a traditional children's game involving trying to catch dragonflies. And historically, one of the ancient names for Japan was Akitsushima, which means Dragonfly Island.
Dragonfly Island, wow. So in many cultures, they seem to be viewed quite positively as symbols of good things. But I feel like I've also encountered some more negative, maybe slightly sinister associations.
That's very true, especially in European folklore. Dragonflies have often been regarded with suspicion, even fear. You see it in old folk names.
Like what?
Names like horse stinger or devil's darning needle or ear cutter. These reflect a common, though totally unfounded, belief that they could bite or sting humans or livestock or even sew up people's ears or eyes while they slept.
Ouch, that's quite a reputation.
Totally undeserved. They don't sting and rarely bite humans unless handled carelessly. In Swedish folklore, it was said that the devil used dragonflies to weigh people's souls. In Norway, they were called eye poker, and in Portugal, eye snatcher.
Yikes.
They were also often associated with snakes, probably because they're both found near water. You get names like adder servant in Wales or snake doctor and snake feeder in the southern United States.
From symbols of purity and courage to devil's darning needles and eye pokers, quite a spectrum of interpretations. Have they inspired our more formal arts as well, like poetry and literature?
Certainly. Lafcadio Hearn, the writer who spent many years in Japan, often commented on just how prevalent dragonfly imagery is in Japanese haiku. The great poet Matsuo Basho, for instance, included dragonflies in several of his famous haiku, often linking them beautifully to the feeling of autumn.
Okay.
In English literature, Lord Tennyson, in his long poem The Two Voices, used the image of a dragonfly emerging from its drab larval skin into its winged adult form as a powerful metaphor for transformation and spiritual awakening.
Oh, that makes sense.
And the nature writer H.E. Bates, in his book Down the River, wrote very admiringly about their incredible flight, capturing that sense of freedom and agility.
It's fascinating to see how these creatures have sparked human imagination across so many different cultures and art forms. Has our modern fascination with dragonflies extended into the realm of technology at all? Have we learned anything from them technologically?
It has, actually, in a very innovative, perhaps slightly futuristic way. Scientists and engineers have been studying the unique flight capabilities and sensory systems of dragonflies for inspiration in developing micro-aerial vehicles, or MAVs, tiny flying robots.
Learning from their flight mechanics.
Exactly. But it's gone even further. There's been research into creating genetically modified cyborg dragonflies, sometimes called dragonflies.
Cyborg dragonflies,
Yes.
seriously.
Seriously. In these experiments, researchers have modified neurons in the dragonfly related to steering to be light sensitive. Then they attached tiny microelectronic backpacks with sensors, a small solar cell, communication devices onto the adult dragonflies.
A backpack on a dragonfly.
Yeah. By directing pulses of light to specific steering neurons via tiny optical fibers in the backpack, they've been able to exert a degree of control over the dragonfly's flight direction.
Controlling a dragonfly with light.
To some extent, yes. The idea is that these could potentially be used as highly maneuverable, energy-efficient platforms for things like surveillance or environmental monitoring in hard-to-reach places. Still very much in the research phase, though.
A cyborg dragonfly. That's an incredible leap from ancient folklore about devil's darning needles to cutting-edge biohybrid technology. What a journey we've taken in this deep dive into the world of dragonflies.
Indeed. It's been quite a ride, hasn't it? From their incredibly ancient origins and remarkable biology, those eyes that flight to their global distribution, their complex behaviors like territoriality and that intricate mating dance,
Wow.
and their diverse, sometimes contradictory cultural significance around the world. Dragonflies are truly captivating creatures. We've explored their amazing adaptations, their lifestyles as predators in both water and air, and sadly, the serious challenges they now face in our rapidly changing world.
It's been absolutely packed with surprising facts and fascinating insights. Thinking about those ancient lineages stretching back hundreds of millions of years, their almost total surround vision, the breathtaking aerial acrobatics, those intense territorial disputes, and the completely different ways humans have viewed them. Who knew there was so much to discover about these often overlooked insects?
It really highlights the endless wonders you can find in the natural world, doesn't it? And how interconnected everything is.
Definitely. So as we bring this deep dive to a close, here's maybe a final thought for you, our listener. Considering the dragonfly's incredibly long evolutionary history, surviving mass extinctions, adapting to countless environmental shifts, developing such unique tools for survival, what lessons might these ancient aviators hold for us as we navigate our own rapidly changing world?
That's a good question to ponder.
Perhaps the next time you're near a pond or a stream, and you see a dragonfly flitting past, maybe catching the sun on its wings, you'll take just a moment longer to observe it. Maybe with a newfound appreciation for its remarkable journey through deep time and the vital role it plays, often unseen in the delicate balance of our ecosystems. Maybe you'll even see it as a tiny, iridescent, living symbol of resilience. Ever find yourself wondering what dinner looked like for our well, you get the picture, ancestors way back in the Stone Age?
Yeah, way, way back.
Today, we're doing a deep dive into the Paleolithic diet. You might also know it as the Paleo Diet, maybe the Caveman Diet, or Stone Age Diet. Lots of names.
Fundamentally, it's a modern way of eating, really. It encourages choosing foods that, well, proponents believe were available to humans during the Paleolithic era.
Which was a huge period, right? Like 2.6 million years ago up to around 10,000 years ago?
Exactly. A massive stretch of time.
Yeah.
And the idea is to eat like people did back then.
Okay. And to really get our heads around this, we've dug into the Wikipedia page on a Paleolithic diet. It's pretty comprehensive.
Yeah, it covers a lot of ground. The history, the foods, what's in, what's out, the health claims people make for it.
What science actually says, how popular it's become. It's all in there.
So our goal today is to kind of sift through all that, like an archaeological dig, but, for information.
Right. We want to give you a clear picture of what the paleo diet actually is, the arguments for and against it, and, crucially, what the science really tells us.
What does the evidence say? That's the key question.
Okay, so let's start right there. When someone says paleo diet, what foods are we actually talking about? What's on the menu?
Generally, it emphasizes vegetables, fruits, nuts, roots, meat, including organ meats often.
Organ meats, interesting.
Yeah, definitely part of the picture for many proponents. Eggs sometimes get included too.
And what's definitely off the menu? What gets the prehistoric thumbs down?
The big exclusions are dairy products, grains, any kind of grain sugar, legumes like beans and lentils, processed oils, salt, alcohol, even coffee.
Wow, okay. That cuts out quite a lot of typical modern staples. It sounds very much like a back-to-basics approach, really focusing on whole, unprocessed foods.
That's a really key element, yeah. Avoiding modern food processing is central to the whole idea, prioritizing what are seen as more quote-unquote natural food sources.
Makes sense. Thinking about a time before factories and, well, supermarkets.
Yeah.
Now, this whole idea of eating like our ancestors, it didn't just pop up recently, did it? There's a history here.
Oh, definitely not. You can see sort of early sparks of these ideas about primitive diets way back in the 19th century, actually.
Really? Like who?
Well, there was a guy named Emmett Densmore who famously declared that bread is the staff of death.
Wow. Strong words.
Very strong. And interestingly, on the other side, you had John Harvey Kellogg, yes, that Kellogg, who actually argued for a diet rich in starches and grains. He thought that was closer to what ancient people ate.
So, completely different tastes even back then. Fascinating. When did it start looking more like the paleo diet we hear about today?
Things started to crystallize a bit more in the mid-20th century. Arnold de Vries wrote a book in '52, Primitive Man and His Food.
Okay.
Then Richard McCarness in '58 suggested a low-carb Stone Age diet in Eat Fat and Grow Slim. Some people see that as an early nod towards the weight loss angle of modern paleo.
Interesting. So a few people were exploring the idea, but who really pushed the meat-centric version?
That was probably Walter L. Volkland, a gastroenterologist. His 1975 book, The Stone Age Diet, really championed meat. Very limited veggies and starches.
And his argument was?
He basically stated that humans were exclusively flesh eaters until about 10,000 years ago. A very strong claim.
Yeah, no kidding.
Yeah.
But it feels like the current version, the one that got really popular, came a bit later and had a slightly different emphasis.
You're absolutely right. A pivotal moment was 1985. Stanley Boyd Eaton and Melvin Konner published this really influential article in the New England Journal of Medicine.
What was their main point?
Their core idea was that modern humans are still biologically very similar to our pre-agricultural ancestors, almost like we're, genetically wired for pre-agricultural foods.
The discordance hypothesis. That's the term you hear a lot, right? Can you break that down a bit?
Yeah, essentially, it's the idea that there's a mismatch, a discordance, between our ancient biology, our Stone Age genes, if you will, and our modern diet and lifestyle.
Full of processed foods and things our ancestors never saw.
Exactly. And this mismatch, they proposed, is the root cause of many modern chronic diseases. Obesity, diabetes, heart disease, and so on. Like running new software on old hardware.
That makes intuitive sense as a starting point. So how did that academic idea turn into such a huge diet trend?
Right, that's where Loren Cordain comes in. He has a background in health science and physical education. In the early 2000s, he really popularized these ideas with his book, The Paleo Diet.
Published in 2002, I think.
That's right, and he actually trademarked the name The Paleo Diet. His version tended to put a bit more emphasis on animal products compared to what Eaton and Konner first suggested.
So Cordain really became the face of the modern paleo movement, and it caught on fast.
It really did. By 2012, people were calling it a latest trend in dieting, driven a lot by the books. And then get this, in 2013 and 2014, it was the most searched weight loss method on Google.
Wow. Top of the Google searches. That's huge. And it wasn't just a quick fad. It seems to have had staying power.
Definitely. By 2019, the estimate for the whole paleo diet industry, books, food products, services, all that was around $500 million.
$500 million. That's serious money. Clearly, a lot of people bought into the idea of eating like our ancestors. Now, you mentioned earlier it's a reimagining, not a perfect copy. Why is that distinction important?
Oh, it's absolutely crucial because we simply can't perfectly recreate those ancient diets. And frankly, in some ways, we probably wouldn't want to.
Oh, so?
Well, think about food availability. It was incredibly variable, seasonal, dependent on migrations, plus some actual Paleolithic practices like occasional cannibalism in certain groups, obviously not part of the modern diet plan.
Right. Good call. Let's leave that one in the past. So, the principle is ancient, but the practice is modern. And you mentioned the specifics can vary too, even among paleo advocates.
That's a really key point. Eaton and Konner's original vision back in '88 actually described a diet that was surprisingly plant-heavy, maybe 65% plant-based calories.
Really? That's not the impression many people have.
No, because the versions popularized later, like Cordain's, tend to emphasize animal products much more. So there isn't just one single paleo diet, strictly speaking. There's variation within the movement.
That's a big difference, mostly plants versus leaning more towards meat. Now, one thing that's almost always out is dairy. What's the thinking there?
The main rationale is historical. Animal domestication, and therefore milking animals for food, didn't really happen on a wide scale until after the Paleolithic, with agriculture. So the argument is simple. Our Paleolithic ancestors didn't drink milk besides mother's milk as infants.
Okay, that makes sense chronologically. But digging into this whole ancestral diet idea, it feels like it gets complicated pretty quickly, doesn't it?
It really does. Marion Nessel, the molecular biologist, makes a great point. She says our knowledge of the exact proportions of animal versus plant foods back then is actually pretty limited. It's often based on, circumstantial evidence, and there's a lot of debate.
So we can't just point to one specific menu and say, that's it.
Exactly. She argues we just don't have enough solid data to definitively say this is the single optimal diet from that era determined by our genes. It's more like a rough sketch based on limited clues, not a blueprint.
And Nestle also suggests the evidence might even point towards plant-based diets being pretty healthy back then.
Yeah, she suggests that the available evidence could support the idea that diets largely based on plants promoted health and longevity, especially when people were active and food wasn't scarce. The idea of paleo as a very specific set of rules is really just a hypothesis.
And what about the data used by proponents like Cordain? Has that been looked at critically?
Yes, it has. For instance, the data for his main book relied heavily on studies of only 6 contemporary hunter-gatherer groups. And critics point out many of these groups live in pretty marginal environments,
Like where?
places where food options might be limited or very specific, like the Kung in Africa, where one study only looked at their diet for a month, or the Inuit in the Arctic, who have a very unique high-fat diet adapted to the cold.
So relying on those groups might give a skewed picture of what all Paleolithic people ate everywhere.
That's the criticism, yeah.
Right.
It's a bit like trying to understand global cuisine by only looking at Arctic or desert diets. And another huge point is that the foods themselves have changed dramatically.
What do you mean, like, our broccoli isn't Stone Age broccoli?
Not even close. Broccoli, cabbage, kale, they're all modern cultivars bred from a single wild plant, Brassica oleracea. They didn't exist like this back then. Or think about wild almonds, they contain cyanide. We've bred that out of the ones we eat.
Wow, okay. Cyanide almonds. Another thing to leave in the past. That really shows how different the ingredients are, even if we tried to eat the same things.
Precisely. And look at modern hunter-gatherers. Their diets vary enormously. You've got groups like the Gui in Africa getting maybe 25% of calories from animals, while the Alaskan Nunamiut might get up to 99%.
So massive variation.
Huge. And these groups often have specific genetic adaptations to their particular diets, which really undermines the idea of one single ideal ancestral diet for everyone today.
Plus activity levels, right? Hunter-gatherers were likely way more active than most of us.
Absolutely crucial point. Their high activity levels probably protect them significantly from things like heart disease and diabetes. You can't just adopt the food list without the lifestyle and expect the same results, especially in a mostly sedentary modern world.
So simply eating paleo foods might not cut it. Was there a review that looked into this?
Yes, a 2018 review concluded that the paleo diet's recommendations were based on questionable research and were difficult to reconcile with detailed studies of actual hunter-gatherer diets. Pretty strong words.
Yeah, that sounds like a significant critique. And what about the idea that our ancestors didn't eat starches or grains? Is that holding up?
That's being questioned too. Some researchers propose that cooked starches might have been really important for fueling our growing brains during evolution.
How would that work?
Well, there's evidence related to the amylase gene, the enzyme that helps digest starch. Humans have variable numbers of copies of this gene, suggesting that being able to efficiently digest starches could have been an evolutionary advantage.
So maybe the completely starch-free, grain-free picture isn't quite accurate either. Okay, let's pivot to the health effects. Proponents claim some big benefits. What's the evidence actually show?
Well, first off, it's important to note that the quality of the research specifically on the paleo diet is often described as, let's say, poor to moderate methodologically.
Not ideal.
Not ideal. And some of the really big claims, like reversing diabetes or curing autoimmune diseases, those are generally seen as exaggerated and aren't well supported by strong evidence. There's been a lot of debate around those claims.
Okay, so temper the expectations on the miracle cures. But are there any positive aspects generally agreed upon?
Yes, definitely. Following a paleo pattern usually means cutting way down on processed foods, added sugars, and excess salt. And those changes align well with mainstream dietary advice and are generally good for most people's health.
So the whole food focus is a plus.
Absolutely. And in that sense, it shares similarities with other healthy patterns like the Mediterranean diet, which do have strong evidence behind them for long-term health compared to a standard Western diet. So emphasizing whole foods is likely beneficial regardless of the paleo label itself.
Right, but what about downsides, potential risks?
There are potential nutritional gaps. Cutting out dairy entirely can make getting enough calcium and vitamin D tricky, which is important for bone health.
Good point.
Some people also report side effects, especially when starting things like weakness, diarrhea, headaches. And if the diet encourages eating a lot more fish, there could be a higher risk of mercury or other toxin exposure.
Okay, things to be aware of. What about weight loss? That seems to be a huge driver for people trying it.
There is some evidence it can lead to weight loss, particularly short-term. This is likely because the foods emphasized protein, fiber from veggies, and fruits tend to be more satiating, making you feel fuller.
You might just naturally eat fewer calories.
Exactly. It can lead to a calorie deficit. Some studies show initial improvements in weight and body fat, but whether those benefits stick around long-term isn't always clear. Like any diet causing a calorie deficit, it can work for weight loss, initially at least.
Makes sense. But what about the bigger claims preventing heart disease, metabolic syndrome?
Currently, there isn't strong, consistent evidence to say the paleo diet significantly reduces the risk of cardiovascular disease or metabolic syndrome compared to other healthy diets. Same goes for treating inflammatory bowel disease. The evidence just isn't robust.
And the meat focus. Any concerns there?
Yeah, that's a point worth noting. Similar to discussions around the Atkins diet, if a paleo approach involves eating large amounts of red meat, especially fattier cuts, that could potentially increase cardiovascular risk for some people based on broader dietary research.
Okay. So the major disease prevention claims seem a bit shaky, scientifically speaking. Let's just to the why again. What's the core logic proponents use?
The central argument, as we touched on, is that our genes haven't really changed much in the last 10,000 years since before agriculture. So, the diet from the Paleolithic era is supposedly the only one that perfectly fits our genetic makeup.
Lauren Cordain's line, the one and only diet.
That's the one. The idea is our bodies just haven't adapted to handle grains, dairy, legumes, all the post-agricultural foods.
And the diseases of affluence are the result of this mismatch.
That's the argument. But a counterpoint often raised is lifespan. Maybe hunter-gatherers didn't get those diseases as often simply because they didn't live as long, on average, as people in affluent societies do today.
Right, they might not have reached the ages where those diseases typically manifest. And the evolutionary discordance hypothesis, and that's the scientific term for this mismatch idea.
Yes, exactly. It posits that chronic diseases arise from this disconnect between our Stone Age genes and modern lifestyles, with diet being a huge part of that lifestyle. The paleo diet recommendations are basically a direct application of this hypothesis.
But it sounds like scientists aren't all convinced by this hypothesis, or at least think it's maybe too simple.
You're right. Critics argue it's a bit oversimplified. It kind of glosses over how incredibly flexible and adaptable humans have been with diet throughout history. We can thrive on a very wide range of foods.
We're dietary generalists, in a way.
Pretty much. And we have clear examples of genetic adaptation to new diets after the Paleolithic.
Like digesting milk.
Lactase persistence is the classic example. The ability for adults in some populations to digest milk sugar evolved after animal domestication. If we were so rigidly stuck in the Paleolithic, how did populations successfully adopt agriculture with its grains, dairy, and legumes? Arguably, those foods would have been detrimental if we couldn't adapt at all.
So our genes aren't frozen in time, they've continued to evolve.
Exactly. And DNA analysis from ancient human remains keeps showing more and more evidence of ongoing adaptation to different diets long after the Stone Age. It directly challenges that core paleo premise.
So scientists are pushing back on the no evolution since the Stone Age idea.
Strongly. Marlene Zook, an evolutionary biologist, basically says it's a misconception that our genes are identical to 10,000 years ago, and that even 10,000 years is plenty of time for significant evolutionary changes in digestion.
And others agree.
Oh, yeah. Paleoanthropologist Peter Unger flat out calls the paleo diet a myth, both because there wasn't one single Paleolithic diet, it varied hugely by time and place, and because humans are always evolving.
A work in progress.
Exactly. And Anne C. Stone, an anthropological geneticist, is quite emphatic. She says basically, it drives me crazy when paleo diet people say we've stopped evolving. We haven't. The evidence shows adaptation to agriculture.
So the scientific consensus seems to be that the genetic argument for paleo is, well, flawed.
That seems fair to say. Even Melvin Konner, one of the original discordance hypothesis proponents, has suggested that maybe the biggest dietary challenges for our ancient genes haven't come from agriculture itself, but from much more recent ultra-processing of food, say in the last few hundred years.
That's a really interesting nuance. Maybe it's less about grains and dairy themselves and more about turning them into, I don't know, sugary cereals or processed cheese.
Potentially, yeah. It shifts the focus from the types of whole foods to the degree of processing.
Okay, interesting. Now, shifting gears again slightly, what about the environmental impact? Especially with that meat focus.
That's a growing concern. A 2019 analysis looking at U.S. diets actually ranked the paleo diet as more environmentally harmful than a standard omnivorous diet.
More harmful. Why?
Primarily because of the higher meat consumption it often entails. Meat production generally has a larger environmental footprint: land use, water use, greenhouse gas emissions. In that study, only the keto diet ranked worse environmentally.
Wow. That's significant.
Yeah, author Elizabeth Colbert echoed this, prolonging the paleo diet potentially an environmental disaster because meat is so resource-intensive to produce compared to plants.
Definitely something to factor in, especially today. Okay, finally, let's talk about its popularity and the whole scene around it. It's more than just food, right?
Oh, absolutely. It's become a whole lifestyle, almost an ideology for some. You see paleo-branded everything, cookbooks are bestsellers, there are apps, snacks, even clothing sometimes.
That $500 million market you mentioned.
Exactly. And despite the scientific questions we've discussed, that market keeps growing. It shows a really strong consumer pull.
And how is it marketed? What's the appeal?
A lot of it relies on an appeal to nature, this idea that natural equals better or healthier. Sometimes you even see hints of conspiracy theories, like suggesting mainstream nutrition advice is wrong because of influence from the food industry, or even a vegetarian lobby. And sometimes products get labeled paleo-approved, even if the link to actual Paleolithic eating is pretty tenuous.
So it taps into distrust of modern systems and a desire for something seemingly simpler or more authentic.
I think that's a big part of the appeal, yeah. It's a fascinating mix of diet, history, marketing, and culture.
It really does sound like it. So let's try and sum this up. The paleo diet is this modern take, based on ideas about ancient eating habits.
Right, based on certain assumptions about the past.
It might have some short-term benefits, mainly because it cuts out processed stuff, which aligns with general health advice.
True, the whole food aspect is generally positive.
But many of the big health claims lack strong scientific backing. There are potential nutritional downsides, and maybe environmental ones too. And that core idea that our genes are stuck in the Stone Age seems pretty debatable according to evolutionary science.
Yes, the evidence for ongoing human evolution, including adaptation to diet, is quite strong and challenges that fundamental premise.
So what's really interesting is thinking about why this idea holds such appeal. This return to a supposedly simpler, more natural way of eating.
It definitely seems to resonate with a desire for health, maybe a distrust of modern food systems, but it might be based on a bit of a romanticized, maybe not entirely accurate view of the past.
And that brings us to our final thought for you listening. Given everything we know now about human evolution, our adaptability, the sheer diversity of diets humans have thrived on, does trying to rigidly stick to one specific idealized version of a past diet really make the most sense for our health today?
And what does that fascination with a specific natural past tell us about our relationship with food right now and the stories we construct about what's truly optimal for us?
It definitely raises questions about how we use history, or interpretations of history, to guide our choices today. Lots to think about.
It certainly is. It underscores the need for critical thinking when evaluating any dietary trend, really.
Absolutely. We always encourage you to keep exploring, maybe talk to qualified nutrition professionals if you're considering big dietary changes, and just approach all this health information with a curious and critical eye.